There have been over 6,000 exoplanets discovered outside the solar system as of the time I'm making this video. We know next to nothing about most of them, but there are a good amount of planets outside the solar system where we can actually say a few interesting things about their environments and characteristics. However, exoplanet content online is usually limited to just a fraction of planets, and the vast majority of these worlds are almost never talked about. This is one of the main reasons why people don't know there are over 100 exoplanets that have been officially named. Most exoplanets are referred to by their scientific designations, the string of numbers and letters people are familiar with. These designations are obviously not very good names, so every once in a while the International Astronomical Union allows the public to give some of these planets official names, and 164 exoplanets so far have been named this way. How an exoplanet actually gets named is a topic I've covered in previous videos. What I haven't done before is a deep dive into every single exoplanet that has an official name. So that's what this video will be about. I'll be ranking all 164 officially named exoplanets by how scientifically interesting they are, from worst to best. This is going to be a pretty long video, and of course the most interesting planets will be toward the end, but hopefully by the end you'll have a better idea of not only these 160 or so worlds, but also the current state of exoplanet science in general. So I'm not going to waste any more time with the intro and just get into it. The lowest planets on this ranking will be, somewhat obviously, the planets that don't actually exist. There are a handful of planets that were given official names that turned out to be false positives and not actually be real. So at number 164, at the very bottom of the list, I'll be putting Orbitar. Orbitar, also referred to by its designation 42 Draconis b, was an exoplanet suspected to be orbiting the star Fafnir, at least 4 times the mass of Jupiter on a mildly eccentric orbit. However, it was later found to not actually exist, and the radio velocity data thought to be a planet signal was actually stellar activity. For the rest of this list, I'll also be talking a bit about what the exoplanet's name actually means. There are dozens of different cultures across the world that now have their names represented among the stars, and I think that's really cool, and glad that people aren't limiting themselves to Greek and Roman gods. That being said, Orbitar's name means nothing. It's a completely made-up word, which is actually in violation of the IAU naming rules. How the name got approved is beyond me, but doesn't really matter because Orbitar doesn't actually exist. With that out of the way, planets 163, 162, and 161 will go to Arcus, Spey, and Thestius. To avoid having to say them every time, the planet's scientific designation will be on screen along with the spelling of its name. These 3 planets are all gas giants, which will be a common theme throughout this video, that orbit stars visible from Earth without a telescope. Thestius is particularly interesting because it orbits Pollux, the brightest star in the Gemini constellation. This trio of worlds is pretty similar to one another, with all 3 taking a few hundred days to orbit their stars. Spey and Arcus take around 190, and Thestius around 590. All 3 are bigger than Jupiter as well. However, the reason they're so low on the list is because all 3 of these planets are disputed and may not exist. Like Orbitar, their planetary signals may just be stellar activity in disguise, but unlike Orbitar, as of the time of making this video, they have not yet been conclusively disproven. Their existence for now is just unlikely. Arcus is the son of Zeus and Callisto in Greek mythology, Spey is the Latin word for hope, and Thestius is a mythological king of a Greek island. 160 goes to Dagon, a planet that was thought to be orbiting the star Fomalhaut, another star visible without a telescope. Dagon was discovered with direct imaging, but it later turned out that the imaged object was actually an expanding dust cloud, not a planet. So Dagon as a planet doesn't exist, but the dust cloud we thought was a planet does, making it, at least in my opinion, slightly more interesting than the planets that turned out to be stellar activity. It's named after a god of fertility worshipped in ancient Syria. 159 is Lipperhey. It hurts me to put this planet so low, but like the ones before it, there are doubts on its existence. Lipperhey is the outermost known planet of the 55 Cancri system, a very famous exoplanet system that I'll spoil and say one of its members made the top 10 on this list. Lipperhey is named after a European astronomer, and if it exists, would have an orbit similar to Jupiter's, but a mass at least 3 times higher than Jupiter's. For more information about this planet, you can check on my grand tour of 55 Cancri, but essentially the current evidence for Lipperhey's existence is not strong enough to confirm it actually exists. However, additional observations will need to confirm its status as a planet. With number 158, we finally get to objects that definitely exist. The 158 spot will go to Tundra, an exoplanet orbiting a large subgiant star Tamir, at a similar distance Earth orbits the Sun. While it is definitely confirmed that Tundra exists, there's some uncertainty over whether or not it's a planet or a star. A 2020 study suggests its mass could be as high as 345 Jupiter masses, which would make it a red dwarf star, but a 2026 study found a far lower mass, with some uncertainty around 1.2 Jupiters. So it may be a planet, but there's also the chance it's a star, which is why I'm keeping it low on the list. The word tundra means nap in Bengali. So number 157 will be the first object that not only definitely exists, but is definitely a planet, and that spot goes to Iolaus. Iolaus is a hot Jupiter, meaning it's a gas giant with a very short orbit. Iolaus takes just 4.6 days to orbit its star, which is similar to the Sun and named Lerna. It's fairly similar to Jupiter in minimum mass, but unfortunately this is all we currently know about this planet. All of the planets are at the bottom of this list will be at the bottom not because they're uninteresting necessarily, but simply because we know nothing about them. Hot Jupiters are a very interesting type of planet, but there are two reasons I'm putting a lot of them low. The first being we know nothing about Iolaus except it exists, and second, for some reason the IAU named like 100 hot Jupiters. The next 21 planets on this list are all hot Jupiters. This is because in 2019, every country on Earth got assigned a planet to name, but instead of choosing interesting planets, the IAU wanted to be fair and gave every country a similar planet, all gas giants. This is why of the 164 named planets, only 8 are rocky. So I'm going to try to get through these next planets quickly so we can get to the more interesting ones. Iolaus is named after the nephew of Heracles in Greek mythology. 156. Viculus. Viculus is a hot Jupiter taking 2.7 days to orbit its star, which is slightly larger than the Sun. Viculus transits its star, so we know its true mass, and the planet is about 3.5 times larger than Jupiter and 10% larger than Jupiter in radius. However, it has not been studied beyond this, so its exact temperature and composition is unknown. All we know is that it's big and hot. Viculus is the Latin word for little village. Why so many of the lowest planets on this list are all named after Greek and Latin things is beyond me. 155. Ibirapita. Ibirapita is named after a species of tree native to Uruguay and Brazil. It takes 2.8 days to orbit its star, which is about 80% the size of the Sun. However, unlike Viculus, Ibirapita doesn't transit its star, meaning only its minimum mass is known. Ibirapita is at least 25% the mass of Jupiter, but may be larger depending on its unknown orbital inclination. Its temperature and composition are all unknown, but it's a hot Jupiter, so it's going to be hot. 154. Eiger. Eiger is not to be confused with Aegir, which is 27 on this list and we'll get to in like an hour. It's named after a mountain in the Swiss Alps, but is another hot Jupiter. It takes a little less than 11 days to orbit its star, which is 92% the mass of the Sun. This makes Eiger likely slightly cooler than Viculus and Ibirapita, though not significantly so. As the entries go on, there will be more information about these planets than this. The reason these ones are at the bottom is because we know nothing about them. 153. Leet. Leet is extremely similar to Ibirapita, with a similarly sized star, though it takes 4.1 days to orbit it. Its minimum mass is also pretty small, at least 45% the mass of Jupiter, though it may be larger. A 2007 study suggests the planet's true mass might actually be 62% the mass of Jupiter. Either way, this is another hot gas giant. Only like 50 more of these to go. 152. Kralomach. Kralomach's name means Jupiter. It's named after the ancient Slovak name for the planet Jupiter. This isn't the only planet on this list that's directly named after another planet, however, since we also have Quankoa, but Kralomach is definitely another hot Jupiter, taking 2.7 days to orbit its star, slightly bigger than the Sun. Kralomach is the first planet on this list we can say things about. It's 6% more massive than Jupiter, but 26% larger in radius, giving it a somewhat low density. It's also the first planet on this list with a measured temperature. Kralomach's dayside temperatures are measured at 2,213 degrees Fahrenheit, 1,212 Celsius, give or take about 100 degrees either way. Unfortunately, its atmospheric composition is unknown, unlike the more interesting hot Jupiters we'll get to soon. 151. Zambretta. Zambretta is the only planet on this list with a name that starts with Z, which isn't very interesting, but at least makes it somewhat unique. It's named after an island in Tunisia, but is another hot Jupiter. It's only 12% the mass of Jupiter, which is the smallest planet on this list so far, but about 72% of Jupiter's radius. Zambretta takes about 7.3 days to orbit its star, which is named Zembra, after a different island in Tunisia. 150. Sissy. The planet Sissy is named after the character Sissy from the 1955 Austrian film Sissy. It's about 2.4 Jupiter masses and 10% larger than Jupiter in radius, and has actually been looked at by James Webb. You'd think that means we know interesting things about it, but JWST only looked at it to test the calibration of its instruments. This is because of Sissy's high mass and relatively low radius, which would produce a flat, featureless spectrum since the gases in its atmosphere wouldn't be far enough away from the planet for James Webb to see them. So JWST wasn't actually looking for anything here, it was just confirming that it was working as intended. Sissy's surface gravity is about 7.5 times stronger than Earth's, and takes 4.6 days to orbit its star, named Franz, which is a bit bigger than the Sun. 149. Tume Arandu. Breaking the top 150 is Tume Arandu, which is supposedly unique among hot Jupiters for having a somewhat eccentric orbit. Though as we'll see throughout the course of this ranking, having an eccentric orbit is not at all unique among named exoplanets, which is why I'm putting it so low on the list. It takes 10 days to orbit its star and has an orbital eccentricity of 0.5, which is pretty high. This means whatever temperature Tume Arandu is, it's going to vary throughout the course of its orbit. It's also sometimes difficult to make eccentric planets become tidally locked, but unfortunately we haven't observed this planet enough to see if it is tidally locked or not. Tume Arandu is at least 40% the mass of Jupiter and named after Tume Arandu, a character from the Paraguayan mythology that is said to be the father of wisdom. 148. Macropoulos. Macropoulos takes about 4.2 days to orbit its star, and is very similar to Jupiter in mass and radius, though much hotter, with an estimated equilibrium temperature of 1738 Fahrenheit, 948 Celsius, though that's only an estimate and not actually directly measured. It orbits a star Absolutno, which is slightly bigger than the Sun, and before I move on, I'd just like to point out that the Wikipedia article says the age of the star is 7 billion years plus or minus 7 billion years. So the system is apparently anywhere between 0 and 14 billion years old, or the age range of the entire universe, which is kind of funny and not helpful at all in narrowing down its age. It is, however, a suspected binary star, with a potential dim red dwarf companion on a wide orbit. Macropoulos is named after the Czech play The Macropoulos Affair. 147. Myping. Myping is another hot Jupiter, about 40% more massive than Jupiter and 14% larger in radius. A 2022 study found an upper limit on Myping's albedo. This planet reflects at most 44% of the light that hits it, meaning it potentially has a low albedo, though for now only this upper limit exists. This also constrains its equilibrium temperature to 2048 Fahrenheit, 1120 Celsius, though that's an estimate as not been directly measured. Its star Chao Phraya is about 90% the mass of the Sun, and the star and its planet are named after rivers in Thailand. 146. Tanzanite. Tanzanite is named after the mineral tanzanite, which is found in Tanzania. It's about 2.1 times the mass of Jupiter and 35% larger than it in radius, and takes 2.9 days to orbit a star 50% more massive than the Sun. It has an equilibrium temperature of 3170 Fahrenheit, 1743 Celsius, and the star it orbits is fairly metal-rich. It's pretty similar to all the other hot Jupiters covered so far, and has a circular orbit. 145. Trezub. Trezub is named after the coat of arms of Ukraine, which is a trident. Which, by the way, I'm going to be pronouncing a lot of these names wrong probably, so if you know how to accurately pronounce them, please put them in the comments. I'll try to get as close as possible for all the ones I can, but there are a lot of names in this video where I can't find any references at all for how to pronounce them and just make something up. Anyways, Trezub orbits a star called Berahenia, which is even more metal-rich than Tanzanite's star. More metal-rich stars tend to have larger planets, and Trezub is about 1.9 Jupiter masses and takes 10.8 days to orbit its star. Berahenia might have a few red dwarfs orbiting it, separated by 1,210 and 1,370 AU respectively, though it's not yet been confirmed that these stars are bound to it or not. Trezub is also a bit colder than some of the other hot Jupiters so far, with an estimated equilibrium temperature of 1,167 Fahrenheit, 631 Celsius. 144. Onesilos. Onesilos orbits a star very similar to the Sun in mass and radius named Alasia, but is still a hot Jupiter taking 6.4 days to orbit it. Only its minimum mass is known, and Onesilos is at least 23% the mass of Jupiter, which is actually one of the smallest known planets at the time of its discovery in 2002. Because it doesn't transit, its radius is unknown along with its true mass. Onesilos is one of only 14 or so planets in the universe named after a real person, Onesilos being a physician mentioned in one of the oldest known legal contracts on Earth, the Idalion Tablet, found in Cyprus. 143. Lekle-Solon. Lekle-Solon is one of the longest orbits on this list of hot Jupiters so far, taking 20.8 days to orbit its star on a somewhat eccentric orbit, though not nearly as eccentric as Tume Arandu's. Only its minimum mass is known, but it's at least 17% the mass of Jupiter, and may be larger depending on its orbital inclination. Its temperature is unknown, but it's likely colder than most of the hot Jupiters seen so far, though its star has begun the process of expanding into a subgiant. Lechalsolon's name comes from the phrase Lechalsolon, meaning child in the Pitcairn language. 142. Umbasa. Umbasa has a pretty ironic name, being named after an extremely small ant found in Liechtenstein. Umbasa the planet is nearly double Jupiter's mass, but only 34% larger in radius, giving it a surface gravity about 2.7 times stronger than Earth's, much less than Sissy's, but still pretty high. It takes just 1.3 days to orbit its star, giving an estimated equilibrium temperature of 2,340 Fahrenheit, 1,282 Celsius. 141. Isogel. Isogel continues the trend of hot Jupiters we know nothing about, taking 6.5 days to orbit the star Aniara with a circular orbit. The planet is named after the spaceship pilot Isogel from the Swedish poem about space Aniara. Isogel is at least 96% the mass of Jupiter, but may be larger depending on its orbital inclination. 140. Santa Massa. Santa Massa's star has begun expanding into a subgiant, and despite being only 20% larger than the Sun, has become 2.8 times brighter. This is pretty bad for Santa Massa, which is just 0.03 AU away from its star and takes 2.1 days to orbit it. Its name means clouded in Sanskrit because it's a gas giant, and it's at least 1.5 times the mass of Jupiter, though it may be larger. Orbiting a subgiant is pretty interesting, but Santa Massa, and Lechalsolon for that matter, are both so low on this list because, just like how the IAU decided to name every hot Jupiter ever, they also decided to name a lot of planets around subgiant stars. 139. Gigantea. Hopefully I'm pronouncing this one right since I had to look up the phonetic alphabet of Malta to do it, but Gigantea is named after a temple complex on an island in Malta. It has an eccentricity similar to Tume Arandu's of 0.43, takes 5.5 days to orbit its star, and is 3.3 Jupiter masses, one of the larger planets on this list so far. It's only 20% larger than Jupiter in radius, making another planet with a pretty high surface gravity, also like Sissy or Umbasa. So it likely has some significant temperature variations due to its orbit, and its star is larger than the Sun, so it's going to be pretty hot. 138. Surt. Surt takes 5.7 days to orbit the star Muspelheim, and is named after Surtur, the mythological ruler of Muspelheim in Norse mythology. It's about 76% the mass of Jupiter, but similar to it in radius, indicating it has a somewhat low density. Its star is about 20% more massive than the Sun, and that's pretty much all we know about it. 137. Homeric. Homeric is another hot Jupiter, though it does actually have something somewhat interesting about it. It's misaligned to its star's equator. Most planets orbit along their star's equators, but Homeric's orbit is tilted by about 47 degrees. This is fairly uncommon, but not unheard of among hot Jupiters, and as we'll get to soon, there are named planets that orbit perpendicularly and upside down. Homeric is about 30% more massive than Jupiter and 72% larger in radius, and has an estimated equilibrium temperature of 1,940 Fahrenheit, 1,060 Celsius. It's named after the Estonian word for dusk, and its star Koi is named after the Estonian word for dawn. 136. Ngoyu. After 28 planets, we finally get to the first one where we can say things about its composition. Ngoyu is named after a mountain in Romania and was observed by the Hubble Space Telescope to find chemicals in its atmosphere. Water vapor, carbon dioxide, carbon monoxide, and methane were all reportedly found in Ngoyu's atmosphere in 2010, but these results were unable to be reproduced until 2013 when just water vapor was confirmed to be present. Ngoyu was also apparently the 10th planet ever found by transit, and is 90% the mass of Jupiter but 20% larger than it in radius. It takes 3.9 days to orbit its star, which is extremely similar to the Sun. 135. Babylonia. And after over 20 hot Jupiters in a row, we finally get to a non-hot Jupiter. Babylonia is a warm Jupiter, taking 141 days to orbit its star about 0.56 AU away, a little more than half the distance between Earth and the Sun and further out than Mercury. Babylonia is at least 13% larger than Jupiter, but may be bigger depending on its inclination, with a somewhat high eccentricity of 0.13, orbiting a star a bit bigger than the Sun, but that's all we know about it. It's named after the ancient Mesopotamian kingdom of Babylon. 134. Samagia. Samagia is very similar to Babylonia, with just a longer orbit and higher eccentricity around a brighter star. It was originally thought that Samagia was a hot Jupiter, but later observations confirmed it actually orbited much further out, with an orbital period of about 280 days and an eccentricity of 0.27. This means Samagia gets as close to its star as 0.65 AU and as far out as 1.13 AU. This will cause it to experience temperature variations just much slower than the eccentric hot Jupiters we've seen so far. Samagia's estimated maximum temperature is about 260 Fahrenheit, 127 Celsius, though this has not been directly observed, and it may get as cold as 80 Fahrenheit, 27 Celsius, but again, this is only estimates ignoring any potential atmospheric effects. Samagia is at least 1.3 Jupiter masses, but it may be larger, and its name means togetherness or unity in the Sinhalese language. 133. Equiano. Equiano is another one of the few planets named after a person, specifically Olaudah Equiano, a Nigerian writer and abolitionist from the 1700s who fought to stop the slave trade. Equiano the planet has an extremely high eccentricity of 0.74, higher than Tume Arandu's by a lot, though it is still a warm Jupiter. It's also the first planet on this list besides Lippershey to be in a multiplanetary system, and has a neighboring gas giant designated HD 43197c, about 8 AU further from the star. It has not yet been given an official name, so won't be ranked on this list. Equiano's true mass is unknown, but it's at least 0.5 Jupiter masses, and if it shares the same orbital inclination as HD 43197c, then it could be somewhere around 4 Jupiter masses. It takes about 308 days to orbit the star Amadioha, which is very similar to the Sun. 132. Viriato. Viriato is yet another high eccentricity warm Jupiter, and another one named after a person at that. Viriato is the Portuguese name for Viriathus, a military general from the region Lusitania that tried to resist the expansion of the Roman Empire. It's hotter than Equiano, taking just 44 days to orbit its star, and is less eccentric with an eccentricity of 0.6. Its minimum mass is about 43% that of Jupiter's, and doesn't have any known planetary neighbors. 131. Hiru. Hiru is a much colder planet than all the previous ones, taking 615 days to orbit its star, which itself is about 70% as bright as the Sun. What makes Hiru interesting is that it's estimated that its star is somewhere around the ballpark of 10 billion years old, which if true would make Hiru a very old planet. It's at least 29% the mass of Jupiter, though maybe larger, and has a roughly circular orbit. Its star is also soon to start expanding into a subgiant, so Hiru won't be cold for much longer. Hiru is another word meaning unity, this time in the Makua language. 130. Eberonia. Eberonia is another hot Jupiter, but one of the smallest on this list so far, with a minimum mass just 10% that of Jupiter, though again its orbital inclination is unknown and it could be much larger. But if this minimum mass is close to the true mass, it would likely make Eberonia a hot Neptune rather than a hot Jupiter, which as we'll get to soon is a pretty rare class of planet. It takes 4.9 days to orbit its star and is named after the Eberonese people, a Celtic tribe. Its star is also very similar to the Sun. 129. Isli. Isli is 2.5 times the mass of Jupiter, and because it transits, that's its true mass. It's also 14% larger than Jupiter in radius, and is a hot Jupiter taking 2.5 days to orbit its star. It probably has a high surface gravity due to its large mass and relatively low radius. Its star Tisla is evolving off the main sequence, and despite being just 30% more massive than the Sun, is over 4 times brighter than it, likely making Isli an extremely hot planet, though its exact temperature is not known. Isli and its star are both named after lakes located in the Atlas Mountains in Morocco, and Tisla and Isli also mean bride and groom in reference to a local legend about a couple in those mountains. 128. Fold. Fold is another warm Jupiter rather than a full-on hot Jupiter, taking 68 days to orbit its star. Fold is at least 77% the mass of Jupiter and has a somewhat high eccentricity of 0.12, though not nearly as high as other planets we've seen like Equiano and Viriato. It's named after the Icelandic word for earth or soil, which is ironic because Fold is a gas giant and doesn't have either of those. 127. Neufosui. Neufosui was named in a very similar way to Orbitar, with the word Neufosui translating to revolve around in the Naias language. It takes about 25.8 days to orbit its star with a pretty high eccentricity of 0.42, meaning it gets as close as 0.1 AU and as far out as 0.25, making this a pretty hot planet with temperature variations. Its star is about 10% more massive than the Sun. 126. Xolotl. Xolotl, named after the Aztec god of fire and lightning, is a warm Jupiter similar to Neufosui, taking 27 days to orbit its star, which is named Axolotl. It's at least 70% the mass of Jupiter, though its star is currently a subgiant and on its way to becoming a red giant. So Xolotl is a warm Jupiter around a subgiant, which would be pretty interesting, except the next 8 planets on this list are all also warm Jupiters orbiting subgiants. Like I said earlier, the IAU really liked naming planets that were similar to one another in 2019. 125. Sumamea. I hope I'm pronouncing this right, but Sumamea is at least 75% the mass of Jupiter and takes 842 days to orbit its star, making it of similar size to Xolotl, though has a much wider orbit, further from its star than Mars is from the Sun. Its eccentricity is also decently high at 0.22. You expect Sumamea to be fairly cold, but because its star is a subgiant over 5.4 times brighter than the Sun, this is a fairly warm planet, a bit closer to its star than the inner edge of the habitable zone. This implies that Sumamea used to be in the habitable zone, but due to its star's expansion it no longer is, which is pretty interesting. It's named after the character Sumai Mea, who is from the Peruvian love story The Way to the Sun. Its star is named Inkwell, the other character from the story. 124. Cavion. Cavion is at least 60% the mass of Jupiter and is a similar distance from its star Earth is from the Sun. However, because its star Cava is a subgiant, it's over 10 times brighter than the Sun, making Cavion a warm Jupiter. It takes about 298 days to orbit the star, and its star is about 40% more massive than the Sun. So assuming Cavion has always been where it is today, then unlike Sumamea, Cavion has likely never been in the habitable zone. 123. Independence. Independence is the first planet to break the bottom 25% on this list, though is another warm Jupiter orbiting a subgiant star. It's named after the Haitian Declaration of Independence, and its star is named Citadel after a fortress in Haiti that was built to help secure their independence from France. Unlike the previous warm Jupiters around subgiants, Independence has a low eccentricity, circular orbit around Citadel that takes about 428 days to complete, at a distance of 1.2 AU. It's at least 2.75 times more massive than Jupiter, but maybe larger. Citadel is currently 12 times brighter than the Sun, but like Cavion's star Cava, it's about 40% more massive than the Sun. 122. Arbor. Arbor's star Illyrian is also about 12 times as bright as the Sun, though significantly more massive than Cava or Citadel at 2.5 times larger than the Sun, which is actually the most massive star in this video so far. Illyrian is younger than the Sun at about 3.4 billion years old, but due to its higher mass is already a subgiant and expanding into a red giant. Its planet Arbor is at least 30% larger than Jupiter and 1.6 AU away from the star, on a 705-day orbit. Arbor's eccentricity is not fully known, but it's less than 0.27. It's named after a medieval term for the inhabitants of Albania. 121. Victoria Peak. Victoria Peak is named after Victoria Peak, a hill in Hong Kong. Its star Lion Rock, named after a rock in Hong Kong called Lion Rock, is also about 12 times as bright as the Sun, and Victoria Peak is on a 380-day, 1.2 AU orbit around it. The planet is at least 2.4 Jupiter masses, though interestingly Lion Rock is slightly less metal-rich than most stars, which would make it slightly more difficult, though not impossible, to form planets as large as Victoria Peak around it. It's also about 42% more massive than the Sun. 120. Dopir. Dopir's minimum mass is a bit larger than Victoria Peak's at 2.5 Jupiter masses, and it's 1.6 AU away from its star on a 564-day orbit, around a star that is 16 times brighter than the Sun, named Bel-El, which is also 80% more massive than the Sun. Bel-El is only about 1.6 billion years old, but again, due to its high mass, has already begun expanding into a red giant. Dopir is the name of an area in Senegal containing the water source Bel-El. 119. Madrio. Madrio's star Arcalise is smaller than some of the other subgiants so far, just 9.8 times as bright as the Sun, though is still 61% more massive than the Sun. Madrio is 2.1 AU away from its star on an 883-day orbit, and is at least 2.2 Jupiter masses. It's named after the Madriu Valley in Andorra, a World Heritage Site, and its star Arcalise is named after a mountain, also in Andorra. 118. Naron. Naron's star Bosona is the brightest so far, about 18 times brighter than the Sun, and Naron is about 1.74 AU away from it on a 673-day orbit with an eccentricity of 0.1. It's at least 2 times the mass of Jupiter and was named after the Roman term for a river in Bosnia and Herzegovina, with its star Bosona being an old name for Bosnia itself. 117. Tassili. Tassili has a pretty Earth-like orbit around its star, which lasts 380 days around 1.18 AU away from its star, though it has a moderate eccentricity of 0.15. It's at least 1.5 times the size of Jupiter, orbiting a subgiant star, which is about 6.8 times wider than the Sun, though I can't find a luminosity measurement for it. Tassili is named after a mountain range in the Sahara that contains some of the oldest cave paintings in the world. 116. Xbalanque. Xbalanque and its star Hunahpu are named after twin gods from Mayan mythology that became the moon and the sun, respectively. The star is about 8 times as bright as the sun and is another subgiant, and its planet Xbalanque is about 1.9 times the mass of Jupiter or larger, orbiting a star at a distance of 1.26 AU on a 433-day very circular orbit. Its star is also about 40% more massive than the Sun, like many of the subgiant stars we've seen so far. 115. Sazum. Sazum orbits the brightest giant so far, Formosa, which is about 40 times brighter than the Sun. Sazum is also fairly close to Formosa at 0.76 AU, similar to the distance Venus is from the Sun, on a 157-day orbit. The system is only around 900 million years old, but because Formosa is 2.2 times more massive than the Sun, almost as large as Illyrian, it's already well on its way to becoming a red giant and will likely destroy Sazum when it does. Sazum's orbit is circular and it's at least 1.7 times the mass of Jupiter, and at the time of its discovery was actually one of the least massive known planets around giant stars. Sazum is named after a town in Taiwan, and its star Formosa is a historical name for the island of Taiwan. 114. Ryosar. Ryosar is named after the Sar River, which is featured prominently in the works of Spanish writer Rosalia de Castro, which is who the star Rosalia de Castro is named after, which Ryosar orbits. This makes Rosalia de Castro one of the few people who have a star named after them. Rosalia de Castro is another subgiant, but Ryosar is a hot Jupiter on a 4-day orbit rather than a warm Jupiter, though for now Rosalia de Castro is only 2 times as bright as the Sun, so Ryosar is not terribly different from the other hot Jupiters. It's at least 1.3 Jupiter masses, though maybe larger, and the system has an estimated age of around 7.6 billion years, which makes sense because the star is only 10% more massive than the Sun. 113. Stabarogs. The first planet to break the bottom 50 on this list, Stabarogs is another hot Jupiter around a subgiant like Ryosar, though because it transits its true mass and radius are known. Stabarogs is about 2.2 Jupiter masses and 12% larger than Jupiter in radius, and takes 6.1 days to orbit its subgiant star, which is 4.4 times as bright as the Sun. It's also another eccentric hot Jupiter, with a pretty high eccentricity of 0.3. However, the reason Stabarogs is so high is because it also has a second planet in its system, like Equiano. Also like Equiano's neighbor, this planet, HD 118203c, has not yet been given an official name, so it won't be ranked, but it's pretty similar to Equiano's neighbor, with a high mass of 11 Jupiter masses and a wide 6.2 AU 5,000-day orbit. Stabarogs is named after a Latvian poem, and its star is named Liesma for the same reason. 112. Nikaya. Continuing the trend of named planets with unnamed neighbors, Nikaya similarly has a giant planet on a wide orbit near it, about 4.5 Jupiter masses 10 AU away from the star, called HD 48265c. Nikaya and the second planet star Nosaxa is another subgiant, 3.8 times as bright as the Sun, with Nikaya on a 790-day, 1.87 AU orbit around it. It's also at least 2/3 more massive than Jupiter, though a 2026 study suggests the two planets may be misaligned with each other, similar to Hamarika and its star. Nikaya means brother in the Makovi language. 111. Veles. Veles will continue this trend as it also has a large planetary neighbor, HD 75898c, an 8.5 Jupiter mass planet 7.4 AU away from the star Strybor, which is actually not a subgiant, though is still 2.9 times as bright as the Sun. Veles has a pretty similar orbit to Nikaya, 422 days and 1.2 AU away from its star. It's at least 2.5 Jupiter masses, though maybe larger, and has a somewhat high orbital eccentricity of 0.1. Veles is named after a Slavic deity of earth, water, and the underworld, and its star is named after the Slavic god of wind, and its neighbor HD 75898c is named after nothing. 110. Nakanbe. Nakanbe will unfortunately end the trend of warm Jupiters with planetary neighbors, though it makes up for it because the star it orbits, Maohaun, has a confirmed second star orbiting it called HD 30856b. The two stars are separated by about 100 AU, which is a pretty large separation, though not nearly as wide as some of the other stellar binaries we'll see in this video. Nakan B's star is another subgiant 10 times as bright as the Sun, and Nakan B is on a 1.85 AU, 847-day orbit around it. It's at least 1.5 times the mass of Jupiter, has a circular orbit, and is named after the second largest river in Burkina Faso. 109. Ganha. Ganha will be the last warm Jupiter around a subgiant, for now at least. It's at least 86% more massive than Jupiter, 1.66 AU away from its star on a roughly 2-year orbit. Ganha is named after the ancient capital of Azerbaijan. 108. Wangshu. Wangshu, named after the Chinese goddess of the moon, is another warm Jupiter, though this time, instead of orbiting a subgiant, Wangshu orbits a full-on red giant. Its star is 80 times brighter than the Sun and 13 times wider, so despite orbiting at 1.16 AU, Wangshu is a pretty hot planet, though its exact temperature is not known. Its orbit is kind of eccentric, with an eccentricity of 0.2, and takes 320 days to complete. It's at least 84% larger than Jupiter, though maybe bigger. Wangshu used to be much colder when its star wasn't a red giant, but now it's heating up, and could in theory get consumed by its star in the future. 107. Ramajay. Ramajay is another planet orbiting what's likely a red giant, or at least close to one, though it's significantly smaller than Wangshu's star, just 8.9 times as bright as the Sun. However, Ramajay and Wangshu have very similar orbital distances, with Ramajay being about 1.1 AU away from its star. It's at least 20% larger than Jupiter, and likely significantly colder than Wangshu despite their similar orbits. Ramajay is named after a style of music from Trinidad and Tobago. 106. Regotch. We're back to hot Jupiters with Regotch, though this one is interesting because of its low density. Regotch is about a third the mass of Jupiter, but 33% larger in radius, making it a puffball planet. This is because it's getting heated up by its star, which it's on a 4.3-day orbit around, which causes its atmosphere to puff out and expand. Its temperature has also been directly measured at 2,305 Fahrenheit, 1,263 Celsius, though only on the day side and the night side is likely colder. Water has also been found on Regotch, and it likely has high-altitude clouds, though we don't know what their composition is. Regotch is named after a character from a short story collection from Croatia. 105. Dimidium. Dimidium was the first exoplanet found around a Sun-like star. You might know it as 51 Pegasi b. Though Dimidium is a hot Jupiter with very little actually known about it, so it's low on the list. It's about half the mass of Jupiter, which is where it gets its name from, Dimidium meaning half in Latin, and it has an estimated equilibrium temperature of 1,817 Fahrenheit, 992 Celsius, though that's not been directly measured. There have also been some claims that people have directly detected visible light coming from this planet, though 2022 observations ruled that out, suggesting Dimidium is low albedo with a radius no more than 20% larger than Jupiter's. 104. Neri. Neri orbits yet another giant star, this one about 46 times as bright as the Sun, named Mago. It's on the cooler end of the red clump stage, and Neri is another warm Jupiter around a giant star. It's at least 2.8 Jupiter masses, taking 157 days to orbit Mago at a distance of about 0.6 AU, between Mercury and Venus in the solar system. It's named after the Neri River in Ethiopia, which runs through the Mago National Park. 103. Iztok. Iztok is a pretty large hot Jupiter, 2.7 times the mass of Jupiter, on a 6.9-day orbit around its star, which is actually a normal star 20% larger than the Sun. However, what makes Iztok different from the other hot Jupiters so far is that it's evaporating into space, and this has been directly observed. It's been estimated that Iztok is losing 0.023 Earth masses, or a little over twice the mass of the Moon, into space every billion years due to the heat from its star blasting its atmosphere into space. Most hot Jupiters are doing this, but Iztok is the first one on this list where it's actually been directly observed, which is why it's higher than the other hot Jupiters. Iztok and its star Irina are both named after characters from a Slovenian novel. 102. Krotoa. Krotoa is another planet named after a person, that being a translator for the Khoi people in South Africa during colonial times. Krotoa is about 56% the mass of Jupiter, but 40% larger in radius, making another low-density planet like Regotch on a 4.4-day orbit around its star. A 2020 study found that Krotoa's atmosphere does not contain clouds, and that sodium is present in it. It has a directly measured temperature of 1933 Fahrenheit, 1056 Celsius, similar to many of the other hot Jupiters. 101. Caluche. Caluche is a good example of why a planet's minimum mass, which is the mass I've been using every time I say at least, may not always be accurate to the planet's true mass. Caluche had a minimum mass of about 2.7 Jupiter masses, but astrometry observations from Gaia confirmed that Caluche's actual mass was closer to 14 Jupiter masses, putting it on the border of brown dwarf territory. However, there's a lot of uncertainty about Caluche's true mass, and it's especially complicated by the second planet in the system, HD 164604c, which is about 5 times further out than Caluche and somewhere around 7 to 9 Jupiter masses. For the system to be stable, it may be a possibility that the outer planet may have to orbit in the opposite direction than Caluche, which is pretty weird and not a thing normal planetary systems do. However, because this is not confirmed, I'm keeping Caluche at number 101 on the list. It's 1.3 AU away from its star on its somewhat eccentric 606-day orbit, and the star is actually smaller than the Sun, making Caluche decently cold, assuming it's not a sub-brown dwarf and generating its own heat. Caluche is named after a ghost ship from Chilote mythology that is said to haunt an island off of Chile's southern coast. 100. Buru. The number 100 spot on this list goes to Buru, a hot Jupiter with an outer planetary companion without an official name, HD 83443c. Buru's minimum mass is similar to Saturn's, and it takes 2.9 days to orbit its star, which is similar to the Sun. HD 83443c was thought to be a planet on a 28.9-day orbit around the star, but that was disproven, and the actual planet C is similar to the other planetary companions we've seen so far. 1.5 Jupiter masses, 8 AU away from the star, and on a 22-year-long orbit. It's been proposed that HD 83443c reached this position due to the migration of Buru, which likely used to be further away from the star before spiraling inward. The word Buru means dust in the Doluo language. 99. Bambarouche. Bambarouche is a member of a pretty old system, with the star Mausolai estimated to be between 8 and 12 billion years old, though the younger end of that range is likely correct given the star is only slightly less massive than the Sun and not a red giant. It's spinning pretty quickly for a star because of the existence of its planet Bambarouche, which is about 4 Jupiter masses on a 4.1-day orbit, which is close enough that Bambarouche's gravity is causing its star to spin up and rotate faster. It has an estimated equilibrium temperature of 1850 degrees Fahrenheit, 1010 Celsius, similar to the other hot Jupiters, though more massive than most of the planets seen so far. Bambarouche is named after the Mongolian word for bear cub. 98. Kuptor. Kuptor is another hot Jupiter and orbits the star Dia, which may have a small red dwarf binary companion a few hundred AU away. Kuptor is about 44% larger than Jupiter, takes 2.2 days to orbit its star, and is 24% larger than Jupiter in radius. The temperature on Kuptor's day side has been measured to be 3,317 Fahrenheit, 1,825 Celsius, which is hotter than many of the hot Jupiters seen so far, probably because its star is 5.3 times brighter than the Sun. Kuptor is named after a room for baking and drying used in Mauritius. 97. Albany. Albany, named after the northern Sami word for sky, is another hot Jupiter on a mildly eccentric orbit, though it has one of the most massive planetary neighbors seen so far. The second planet in the system, HD 68988c, is about 15 Jupiter masses and 12 AU away from the star on a 38-year-long orbit. The orbit of the second planet is also more eccentric than Albany's, 0.4 compared to 0.15, which is pretty interesting, and may suggest that there's been some significant gravitational interactions between these two planets in the past. This would also make sense given that Albany and most other hot Jupiters likely formed further out and migrated to their current positions, like Albany's 6.2-day long orbit. 96. Cajahuanca. Cajahuanca's true mass is estimated to be about 1.85 Jupiter masses, though this is not known for certain and assumes it orbits along its star's equator. It also has a minimum mass of about 1.2 Jupiters. Cajahuanca is a warm Jupiter with a fairly eccentric orbit with an eccentricity of 0.27, and is about half an AU away from its star, which is twice the brightness of the Sun. Cajahuanca's name translates to rock looking at the stars in the Nahuatl language, which would be pretty poetic if Cajahuanca wasn't a gas giant. 95. Amatex. Amatex's star is much smaller than most of the stars seen so far, just 64% the mass of the Sun and less than 10% of its brightness. Smaller stars are more common across the universe, but the IAU decided to name planets around larger stars, so named planets orbiting smaller stars like Almatex are pretty uncommon. This planet is at least 35% the mass of Jupiter on a 57-day 0.25 AU orbit around star Coea. Its orbit is also eccentric, but less so than Cajahuanca's, with an eccentricity of 0.17. Almatex is named after the Taino god of the wind. 94. Yan Yan. Yan Yan is a very eccentric warm Jupiter orbiting the star Bubup, which is 37% more massive and 2.3 times brighter than the Sun. Yan Yan orbits the star at a very similar distance Earth orbits the Sun on a 361-day orbit, but its orbit is very eccentric. It gets as close as 0.6 AU and as far as 1.44 AU, which is larger than the distance between Venus and Mars, covered by one planet. Like all the other eccentric planets, this likely gives Yan Yan large temperature variations over the course of its year, though its exact temperature has not yet been measured. Its minimum mass is about 28% that of Jupiter, and its name means boy in the Bunwurrung language. 93. Beirut. Beirut is named after the capital city of Lebanon, and it's on a 24.3-day orbit around its star Phoenicia, which is another smaller star 65% the mass and 30% the brightness of the Sun. Beirut is at least 73% the mass of Jupiter, and because of its close orbit and high mass, is actually causing disturbances in its star's magnetic field. This has been noticeable in stellar activity on Phoenicia correlated to Beirut's orbit, which is something we've seen in a few other planets before. 92. Vetus. Vetus is another puffball planet, less than half Jupiter's mass but 50% larger than Jupiter in radius. This is again because of the heat of its star causing the atmosphere to expand, which makes sense given Vetus takes 4.5 days to orbit its star Tycho. The star is about 2 times wider than the Sun, though I can't find its exact luminosity, which likely makes Vetus one of the hotter hot Jupiters seen so far. Similar to Trezub, Vetus is named after the national coat of arms of Lithuania. 91. Madalitzo. Ending the trend of hot planets, Madalitzo is around another small star just 40% the brightness of the Sun, and is on an 800-day orbit 1.4 AU away from it. However, Madalitzo's orbit has an eccentricity of 0.4, meaning this planet gets very cold, and then actually enters the habitable zone as it gets closer to the star, only to leave it again. There are a few other planets that do this, but I'm putting Madalitzo lower than the rest of them because of its lower minimum mass, at least 10% the mass of Jupiter. This could make it pretty interesting, an eccentric ice giant that sometimes gains Earth-like temperatures, but I think larger eccentric planets may be more interesting. Madalitzo means blessings in the Nyanha language of Zambia. 90. Xolotl. Xolotl is not to be confused with Xolotl, which is number 126 on this list. Xolotl is named after a lake in Nicaragua that was named after the god Xolotl that the planet Xolotl is named after. Xolotl is another cold gas giant like Madalitzo, though with a much more circular orbit, meaning Xolotl is cold for the entirety of its 832-day orbit around its star, about 1.6 AU away from it. The star is only 70% as bright as the Sun, making Xolotl a fairly cold place. It's also much larger than Madalitzo's minimum mass, at least 80% the mass of Jupiter. 89. Ivaga. Rounding out the cool Jupiters, Ivaga is a planet at least 64% the mass of Jupiter at a similar distance away from its star Earth is from the Sun. Though because the star Tappaku is only 60% as bright as the Sun, Ivaga is a relatively cool planet. It does have a pretty high eccentricity of 0.24, but that's not nearly as high as Madalitzo's. Ivaga means sky or paradise in the Guarani language, and the Milky Way was thought to be the road to Ivaga. 88. Toga. Toga is another gas giant orbiting a subgiant, though it's unique because its star is metal poor. As I've mentioned earlier, a star's metallicity is pretty important for planet formation, and stars with lower amounts of metals will form smaller planets. The star Sika is very old, with an estimated age of around 12 billion years, making Toga a very old planet and explaining why it's so metal poor. Planets like Toga are expected to be rare, and there are only a handful of large planets like it around such metal poor stars. Toga is at least 37% the mass of Jupiter, on a somewhat eccentric 1.78 AU 956-day orbit around Sika, which, despite being less massive than the Sun, is a subgiant due to its age, making it twice the Sun's brightness. Toga means earring in the U language. 87. Tadmor. Depending on how you look at it, Tadmor was actually the first exoplanet ever discovered. It was suspected to exist as early as 1988, a few years before the confirmation of the first exoplanets, but was only confirmed in 2003, a decade after the first exoplanets. So Tadmor was not the first confirmed exoplanet, but was the first exoplanet to have evidence for its existence. It's about 9.4 times the mass of Jupiter, making it one of the largest planets on this list, and orbits the star Eris, which not only has a second star around it, but is suspected to be a variable star, where its brightness can shift pretty dramatically. Tadmor is about 2 AU away from Eris on a 904-day, very circular orbit, though is pretty warm due to Eris being 11 times brighter than the Sun. Tadmor is named after the Arabic name for the ancient city of Palmyra in Syria. 86. Rocinante. Rocinante is the first planet on this list from the Mu Arae system, a pretty well-known exoplanet system with 4 planets, all named after characters from the novel Don Quixote. Rocinante orbits the star Cervantes at a similar distance Earth orbits the Sun, though because Cervantes is bigger, Rocinante is not in the habitable zone, though it does receive a similar amount of UV light Earth does. Rocinante is at least 44% the mass of Jupiter, though maybe larger, and is named after Don Quixote's horse. 85. Pyrrhus. Unlike Rocinante, Pyrrhus is in the habitable zone of its star, though it has an orbital eccentricity of 0.24, so those habitable temperatures will vary. Pyrrhus's estimated equilibrium temperature, ignoring any potential atmospheric effects, is negative 91 Fahrenheit, negative 68 Celsius, and it takes about 286 days to orbit its star at 0.78 AU, similar to Venus from the Sun, because its star is smaller than the Sun. Pyrrhus is at least 1.2 Jupiter masses, and named after a character in some Polish science fiction short stories. 84. Guarani. There are a few planets on this list named after things in the Guarani language, like Ivaga, but Guarani is named after the Guarani people themselves, similar to Arbor. Unlike the previous planets with neighbors, Guarani is the outer planet in its system, 1.5 AU away from the star. Its neighbor, HD 23079c, is a hot planet on a 5.7-day orbit around the star, with a small minimum mass just 8 times the mass of Earth. Unfortunately, because it doesn't have an official name, we won't be ranking that one. Guarani is at least 2.6 Jupiter masses on a 735-day circular orbit around the star. Guarani's star is similar to the Sun, so Guarani is close to, but as far as I can tell, not in the outer edge of the habitable zone. 83. Quixote. This is a second planet on this list from the Mu Arae system, named Quixote after Don Quixote from the novel Don Quixote. It's a bit further from the star than Rocinante, making it another cool Jupiter, though with a few planetary neighbors, all with names. It has a somewhat eccentric orbit that takes between 1.3 and 1.7 AU from Cervantes, but that puts it within the star's habitable zone, making Quixote a temperate gas giant just with an eccentric orbit. It's at least 1.6 times the mass of Jupiter and takes 645 days to make a full orbit. 82. Tapao Tong. Tapao Tong is one of the only 2 planets on this list with a space in its name, which is weird especially because there are a few planets I've mentioned already, Tumearandu, Ryosar, and Sumaimea as a few examples, that really should be 2 words but aren't for some reason. Tapao Tong is another cool gas giant, and in a system with 2 other planets, one of which also has a name. They orbit a sun-like star called Chalawan. Tapao Tong is about 2 AU away from Chalawan, making it the largest and innermost planet of the system, at least 2.3 times the mass of Jupiter. Its orbit is also fairly circular. 81. Tapao Gao. We're now halfway through the list, and Tapao Gao is the second planet of the Chalawan system, along with Tapao Tong. The third planet, 47 Ursae Minoris D, doesn't have an official name yet and so won't be ranked. Tapao Gao has a smaller minimum mass than Tapao Tong, at least 47% the mass of Jupiter, and is further out, 3.4 AU away from the star, making it a pretty good analog to Jupiter. Its orbit is much more eccentric, however, with an eccentricity of 0.25. The star and the 2 named planets of the system are named after characters from a Thai folktale, with Chalawan being a mythological crocodile king, and Tapao Tong and Tapao Gao being 2 sisters associated with the tale. 80. Trimobe. The next 6 planets on this list, Trimobe included, are all gas giants that either pass through or are entirely inside the habitable zones of their stars, where temperatures are right for liquid water to exist. Trimobe is at least 2.7 Jupiter masses and has a pretty high orbital eccentricity of 0.34. Though this has not yet been directly measured, it's been estimated that temperatures on Trimobe could vary between about 35 to 215 degrees Fahrenheit, 2 to 102 Celsius, over the course of its 500-day orbit. This probably wouldn't be good for habitability, but Trimobe's large mass does mean it could have some big and interesting moons. Trimobe is named after a rich ogre in Malagasy tales. 79. Ugarit. Ugarit's star is just 35% as bright as the Sun, so Ugarit, with its orbital eccentricity of 0.27 and average orbital distance of 0.7 AU, only stays in the habitable zone sometimes, though I haven't seen any temperature estimates for it. Ugarit's also likely smaller than Trimobe with a minimum mass of about 0.2 Jupiters. It takes 225 days to make a full orbit of the star, and is named after a city where people created the Ugaritic alphabet about 3,400 years ago. 78. Oasis. Despite Oasis's high orbital eccentricity of 0.25, from the best I can tell it seems to spend its entire orbit in its star's habitable zone. This is especially interesting because Oasis's star Nikawi is very similar to the Sun. Oasis has a 463-day orbit around its star with an average separation of 1.3 AU. It's at least 2.1 Jupiter masses and is named after the Cree word for child. 77. Lally-Gurons. Lally-Gurons is yet another mildly eccentric gas giant inside the habitable zone of a Sun-like star, with an eccentricity of 0.36, minimum mass 17% larger than Jupiter, and orbital period of 383 days. It gets as close to its star, which is just 5% dimmer than the Sun, as 0.66 AU and as far out as 1.4. So Lally-Gurons passes through the entire habitable zone and comes out on both the cold and hot ends, which is pretty interesting. It's also a similar age to the solar system, with an estimated age of 4.7 billion years. Lally-Gurons is the Nepali name for the rhododendron, a type of flower. 76. Kereru. Kereru is one of the smaller temperate gas giants so far, with a minimum mass of 0.23 Jupiter masses. But like all the others, its orbit is pretty eccentric, with an eccentricity of 0.36. It's just 0.89 AU away from its star on average on a 330-day orbit, and the star is just half as bright as the Sun, so like the others from what I can tell, Kereru likely doesn't spend its entire orbit in the habitable zone. Kereru is named after the Maori word for the New Zealand pigeon. 75. Braia. Taking a short break from habitable zone planets, Braia is a warm gas-horized giant and member of the 55 Cancri system, the rest of its neighbors we'll get to soon. Braia is at least 15% the mass of Jupiter, though could be larger, especially depending on which of its planetary neighbors its orbit is aligned with, which could give it a mass closer to that of Saturn. Other than that, Braia is a warm ice giant around a K-type star, taking 44 days to orbit the star, and it's this high up mainly because it's in an interesting multiplanetary system. It's not the most interesting, but is starting off the top 75 named exoplanets. 74. Harriet. Harriet is one of my personal favorite exoplanets, but I'm putting it all the way down at 74 because we unfortunately don't know much about it for now. Harriet is another member of the 55 Cancri system and is entirely within the habitable zone of its star Copernicus on a circular orbit, which is a nice change of pace. It takes 260 days to make a full orbit of the star and has a minimum mass about 1/6 that of Jupiter, though depending on which of its planetary neighbors Harriet's orbit is aligned to, the true mass may be closer to Saturn. Either way, Harriet is a temperate gas-horized giant with an estimated temperature somewhere around Earth's with some uncertainty. Harriet is named, like the rest of the planets in its system, after European astronomers. Like all temperate ice giants, Harriet has the possibility for a very interesting environment of liquid water rain and Earth-like gravity despite not having a solid surface, but since none of that is confirmed for Harriet, I'm putting it at 74. 73. Braun. Braun returns us to the hot Jupiters. It's 1.8 times the mass of Jupiter, and that's true mass, and a radius 20% larger than Jupiter. It takes just 1.3 days to orbit its star, which is very similar to the Sun. But what sets Braun apart is its orbit. The orbits of most hot Jupiters are decaying, meaning they're getting shorter over time. But for some reason, Braun's orbit seems to be getting longer, meaning for some reason it's moving away from its star. The orbit seems to get longer by 0.014 seconds every year, which isn't something I've heard of among hot Jupiters before. Braun is named after a character from a collection of Irish folktales. 72. Agouto. Similar to Bambarouche, Agouto's star Atakaraka is spinning faster due to the Gauto's gravitational presence. The planet is about 1.2 Jupiter masses on a 1.5-day orbit and is 1.2 times Jupiter's radius. The dayside temperature is also significantly hotter than the equilibrium temperature, measured around 3,121 Fahrenheit, 1,716 Celsius, which is a few hundred degrees hotter than it should be, ignoring atmospheric effects. Agouto is named after the highest mountain in Togo. 71. Mastika. Like Beirut, it was originally thought that Mastika influenced stellar activity on its star, though later studies confirmed this was untrue, and stellar activity on the star Gumala was not correlated with Mastika's orbit. This planet is pretty much exactly the same mass as Jupiter, though takes just 3 days to orbit its star, at an inclination of 67 degrees. Observations from the Spitzer Space Telescope have also confirmed the presence of carbon dioxide and water vapor on this planet. These same observations also suggested there was a significant difference in brightness between Mastika's day and night sides, which suggested less than 21% of the energy that reaches the planet makes it to the night side, which then suggests some pretty big temperature differences between the light and dark hemispheres, which is common among hot Jupiters. Mastika is a Malay word meaning jewel. 70. Coyopa. Coyopa is another hot Jupiter, and its name means lightning in the Quiche language in Guatemala, which makes sense given its star is named Tojil after a Mayan deity related to rain and storms. This planet is 61% the mass of Jupiter and 20% larger than it in radius, with an estimated equilibrium temperature of 1,877 Fahrenheit, 1,025 Celsius. Why Coyopa is up so high has to do with its system. Tojil is the main star of what one study calls a hierarchical triple system, though they're unsure as to what exactly the third member of the system is, and it could be a red dwarf, a second planet, or a white dwarf, which is pretty exciting. 69. Aleph. Aleph is another puffball planet, 75% the mass of Jupiter, but 40% larger than it in radius. It's also another hot Jupiter on a 3.9-day orbit around its star, but it does transit from our perspective, which would allow for its atmosphere to be characterized. Its star is also 2.6 times brighter than the Sun, making Aleph a pretty hot planet, explaining why it has such an inflated atmosphere. Aleph is named after the first letter of the Hebrew alphabet. 68. Gliese. Gliese is a planet that shares its name with an asteroid in the solar system, which is interesting because the current space object naming rules say repeat names aren't allowed, so I don't know how Gliese slipped through the cracks. The name refers to a type of creature in Finnish mythology. Anyways, Gliese the planet is a puffball like Aleph, just 26% the mass of Jupiter, but 82.5% its radius. It takes 4.6 days to orbit its star and has a measured temperature of 1,488 Fahrenheit, 809 Celsius. Gliese's atmosphere is also analyzed in 2017, and found to contain a lot of water vapor, which suggests it lacks clouds or hazes. 67. Puli. Puli is another puffball, 21% Jupiter's mass but 96% Jupiter's radius, making it puffier than Aleph and Gliese. Unlike Gliese, 2020 observations suggest that Puli's atmosphere was cloudy and hazy, and also had water vapor in it. However, these observations have since been disputed, so Puli's atmospheric structure is unknown for now. It takes 3.2 days to orbit star Komondor, which is just 21% the brightness of the Sun, but still hot enough to inflate Puli's atmosphere. The two objects are named after dog breeds from Hungary. 66. Galileo. This is the fourth member of the 55 Cancri system in this video, and a hot Jupiter. Galileo is at least 80% the mass of Jupiter, though this minimum mass is likely close to the true number, due to the fact that Galileo partially transits Copernicus. This means that only part of the planet passes in from the star from our perspective, so the transit is helpful in constraining the planet's mass, but not its radius or composition. Either way, Galileo is interesting because it's a hot Jupiter with a planet closer to the star than it, Janssen. We'll get to Janssen soon, but this is rare because hot Jupiters usually destroy everything in their path when they migrate inwards, so the fact that there's a planet closer to the star than it is pretty interesting. Galileo takes about 2 weeks to orbit Copernicus, and I'm sure you can guess who it's named after. 65. Dulcinea. Dulcinea is another planet in the Mu-Arae system, and was the first hot Neptune planet ever discovered. Only its minimum mass is known, that being at least 10.5 Earth masses, so Dulcinea being a very hot ice giant is a pretty strong possibility. It takes 9.6 days to orbit Cervantes, though there's some debate as to whether or not this planet has always been a small one, or if it used to be larger but had its atmosphere blasted into space by stellar radiation. For now, we don't know Dulcinia's history for certain. It does have a somewhat high eccentricity of 0.17 though. 64. Kamsa. We're back to planets orbiting red giants for Kamsa, which orbits a star called Chechia that's currently 12 times brighter than the Sun, at a distance of about 1 AU. It's at least 2 Jupiter masses and has a circular 340-day orbit. This is a pretty Earth-like orbit and distance, though Chechia is 1.6 times the mass of the Sun, so it's unlikely that Kamsa was ever anything but hot. It's named after an amulet found in Tunisia. Kamsa is also the 100th planet ranked so far, so every planet after this broke the bottom 100. 63. Taberta. Taberta is interesting for basically being the opposite of a puffball. Observations of it indicate it's a fairly metal-rich planet, with a large metallic core weighing 75 Earth masses. This is pretty large compared to Taberta's 0.6 Jupiter mass, which is about 191 Earth masses total. It's named after a river in the Donbay region in Russia, and takes 2.9 days to orbit its star, which is named Donbay. Taberta is 90% Jupiter's radius, and has a circular orbit and a low albedo. 62. Melquiades. Melquiades is another eccentric Jupiter in its star's habitable zone, though it's near its inner edge rather than fully inside it. It's at least 45% the mass of Jupiter and has an orbit only taking 144 days to complete, though its star is only 40% as bright as the Sun, so it's still pretty temperate. An old 2007 study suggests that the L4 and L5 Trojan points of Melquiades, the areas 60 degrees ahead of and behind it in its orbit, could theoretically be stable enough to host planet-sized objects, which is pretty cool because it's usually hard to keep things in Trojan points for very long, especially entire planets. However, I'm unsure if this remains accurate to this day, especially because a 2026 study found a second planet in the system, HD 93083c, which is at least 5 Earth masses on a 9.6 day orbit around the star. Trojan points are very susceptible to minor disturbances, and this planet could be enough to destabilize them, but that's just speculation and I'm not actually sure about that. Anyways, Melquiades is yet another character from yet another book, that being the Colombian novel 100 Years of Solitude. 61. Parwana. Parwana is another planet like Melquiades in the habitable zone of its star, and was also mentioned in the same 2007 study as having potentially stable Trojan points. Again, that's not actually confirmed, but this planet is of similar minimum mass to Melquiades at 50% the mass of Jupiter, though on a much longer 1.1 AU 493-day orbit. Parwana is named after the Urdu word for moth, because moths circle lights, and this planet circles its star Shama, the Urdu word for lamp. 60. Magor. If you remember from earlier, Magor is like the planet Sissi on steroids. It's 8.7 Jupiter masses, but just 10% larger than Jupiter in radius, giving Magor a crushing surface gravity similar to that of the surface of the Sun. It's named after the legendary ancestor of the Hungarian people, and has a high orbital eccentricity of 0.5 and an estimated equilibrium temperature of 2,312 Fahrenheit, 1,267 Celsius. It takes 5.6 days to orbit its star, and this extremely high gravity also means its atmosphere is extremely condensed. The outer edge of the atmosphere extends just 26 kilometers away from the surface of the planet, with surface in quotes because it's a gas giant. We also have temperature simulations of what weather patterns on Magor might look like over the course of its orbit, as seen here. 59. Bagan. Bagan is another gas giant orbiting a red giant, either 13 or 20 times brighter than the Sun, with some uncertainty. It's at least 3.3 Jupiter masses on a 766-day orbit, and is named after an ancient city and World Heritage Site in Myanmar. But what sets Bagan apart is its potential unconfirmed planetary neighbor. This unconfirmed planet, HD 18742c, will be at least 2.4 Jupiter masses, and very close to Bagan, orbiting a star at 1.96 AU compared to 1.82. This is odd for 2 reasons. 1, giant planets usually don't get this close together, and 2, if this planet was real, the two would be in a 910 orbital resonance, something that has never been seen before. Unfortunately, HD 18742c is an unconfirmed candidate planet for now, and more observations of the system will need to confirm it or rule it out. 58. Somme. Somme is an extremely large planet, about 14 Jupiter masses, and the first planet on this list in the Upsilon Andromedae system, which has 3 planets named after Muslim astronomers. Somme is a warm planet taking 241 days to orbit the star Titouan, which is 3.5 times brighter than the Sun, at a distance of about 0.8 AU. SOM's current eccentricity is about 0.26, but I say current because it's not always like this. This is because of SOM's neighbor Majority, an equally massive giant planet we'll get to soon. Because these two planets are so large, they pull on each other a lot, to the point where SOM's orbital eccentricity goes from very high to very low every few thousand years. Simulations suggest that once every 9,000 years, SOM's orbit becomes circular before becoming eccentric again due to the gravitational influence of Majority. 57. Jebus. Jebus, named after the ancient Roman name for the city of Jerusalem, is about 2 Jupiter masses, 1.2 Jupiter radii, and on a short 1.2-day orbit around its star. It's believed that Jebus's orbit is somewhat unstable, and the planet should be spiraling inward and should be consumed about 7.5 million years from now. However, observations of the planet have failed to detect any signs of orbital decay, suggesting Jebus may not actually be doomed. Either way, it has a cloudless atmosphere and some signs of containing titanium oxide. 56. Smertrios. Like Tiberta, observations of Smertrios suggest it may have a large core, since it's somewhat denser than the solar system's gas giants. Some 2007 estimates suggest the mass of its core may be between 80 and 110 Earth masses, though since that estimate is 19 years old, I'm unsure if it still holds up today. Either way, Smertrios is just 32% the mass of Jupiter and 80% its radius, and has a measured temperature on both its day side and night side. Its day side is 2,788 Fahrenheit, 1531 Celsius, while the night side is 1,400 Fahrenheit, 759 Celsius, which is a pretty big difference. It also has a fairly high albedo of 0.53. Smertrios is named after a Gallic deity of war similar to the Roman Mars, and takes about 2.9 days to orbit its star, which is another subgiant. Its atmosphere is also thought to be oxygen poor, which may be typical of some hot planets. 55. Mulchatna. Like Magor, there are simulations of what Mulchatna's weather patterns might look like over the course of its eccentric orbit, as seen here. This planet is 3.1 times more massive than Jupiter, but similar to Jupiter in radius, and has a high orbital eccentricity of 0.68, which takes it as far from its star as 0.27 AU and as close as 0.05, basically the difference between a warm Jupiter and a hot Jupiter. During the closest approach to its star, Mulchatna receives 27 times more light than it does at its furthest point, and this happens every 21 days. It's named after a river in Alaska. 54. Ayak. I'm definitely pronouncing this one wrong, but Ayak means near in a Waorani language, which is yet another ironic name because it's not nearby. It orbits a very old star, 88% the mass of the Sun, but around 12 billion years old, and extremely metal deficient, making it pretty interesting it has a large planet at all. Ayak's minimum mass is about 40% that of Jupiter, but this is another example of why the minimum mass may not always be close to the true mass, as one study suggested that Ayak's true mass is actually 196 Jupiters, which would make it not a planet and a red dwarf star. However, from what I can tell, the results weren't actually conclusive, so for now Ayak is still likely a planet, which is why I've put it so high, because of how old it may be. 53. Catalinetta. Catalinetta is another rare hot ice giant found on a very close 5.4-day orbit around its star, which is slightly bigger than the Sun. Yet again, Catalinetta is named after a character from a folktale, specifically one from the island of Majorca in the Mediterranean. Sodium has been detected in Catalinetta's atmosphere, and its orbit is aligned to the equator of its star. This is actually kind of strange, since when hot Neptunes like it migrate to their current orbits, they tend to become misaligned, suggesting that Catalinetta didn't undergo any high eccentricity migration to get where it is now. Either it migrated in a different way, or somehow formed where it is now. Either way, it's about a tenth the mass of Jupiter and 63% Jupiter's radius. 52. Mesli. Mesli, named after the Aztec goddess of the moon, orbits a red giant 50 times brighter than the Sun, at a distance similar to Venus and the Sun. It's also an extremely large planet, with a minimum mass 8.3 times larger than Jupiter, and it may very well be much larger. It's on a circular orbit around the red giant, and the system is similar to the solar system in age. 51. Arion. Arion is even larger than Mesli, with an estimated minimum mass of 9.2 Jupiters. It also orbits a red giant, this one named Musica, which is 34 times brighter than the Sun, at about 2.4 AU. Arion is named after, at least from what I can tell, a real person who lived in ancient Greece who invented some musical instruments, though has a bunch of myths surrounding him about being raised by dolphins, which makes sense as the planet Arion is in the Delphinus constellation, literally the dolphin. Arion's star is also a binary, with a small red dwarf companion on a very wide 2200 AU separation away from it. 50. Chura. Breaking the top 50 is Chura, which is interesting for orbiting a red giant that's surprisingly rich in lithium, which is unexpected. The current explanation for lithium in red giants is that it forms during fusion in the star, but there's also some other interesting possibility that it was supplied by a planet the star consumed. That's far from confirmed and not even the most likely explanation, but would be pretty cool. Either way, Chura is at least 2.7 Jupiter masses on a 0.76 176-day orbit around the red giant Kamoi, which is 50 times brighter than the Sun. Chura is a word in Okinawan language meaning natural beauty. 49. Fortitudo. Fortitudo, meaning fortitude in Latin, orbits a younger red giant 70% more massive than the Sun, but 58 times brighter. It has a minimum mass of 2.8 Jupiter masses, but due to observations from the Gaia Space Telescope, it also has a maximum mass of 37.1 Jupiter masses. So it's somewhere between 3 and 37 times the mass of Jupiter. It's on a similar orbit to Chura, 0.68 AU away from its star, which makes Fortitudo a pretty hot place. 48. Hypatia. Hypatia is another very large gas giant around a red giant, but is unique from the last four because it has a very high eccentricity of 0.7, and there's a second planet in the system, Iota Draconis C. Hypatia's true mass has also been calculated by Gaia observations to be about 16.4 Jupiter masses, which is one of the largest planets in this whole list. It orbits a star called Adasich, which is 58 times brighter than the Sun and can be seen from Earth without a telescope. It's 1.4 AU away from its star, and the second planet is 19.4 AU away, of similar mass, 17 Jupiter masses, and also on a high eccentricity orbit. So Hypatia is a hot eccentric Jupiter around a red giant, with another planetary neighbor that is also an eccentric Jupiter. It's named after a poet from ancient Greece. 47. Petrus. Petrus is another highly eccentric gas giant with a very high eccentricity of 0.77. It gets as close to its star as 0.43 AU and as far out as 3.4. Due to this planet's presence, it's unlikely that there are any other planets near the inner system, as simulations show its gravity should have cleared everything further from the star than 0.2 AU, though planets on much further out orbits are still possible. It's at least 1.8 Jupiter masses on a 963-day orbit around the star, and is named after a river in Luxembourg. 46. Hala. Hala is another gas giant orbiting a red giant 52 times brighter than the Sun, though this one is unique because the red giant in question, Baekdu, has already undergone a helium flash and is actually smaller than it used to be. It's been estimated that Baekdu should have expanded out to around 0.7 AU, which is very odd because Hala's orbit is just 0.5 AU, so it should have been consumed when Baekdu was at its maximum extent. However, this was based on what is now an outdated mass measurement for the star, and more recent work suggests Baekdu may have been more compact, allowing Hala to just barely scrape by instead of actually entering the star. Either way, Hala is at least 65% larger than Jupiter, and named after a mountain in South Korea, and even though it may have survived Baekdu once, it won't again, as the star is now expanding again and will fully consume Hala sometime in the next few 100 million years. 45. Guatauba. Guatauba is a hot Neptune which has had its atmosphere observed by a few different telescopes, and found to be made up of about 2.4% water vapor, which seems to be a lot. It's also just 6% the mass of Jupiter, roughly 18.7 Earth masses, which is similar to Neptune. It takes 4.2 days to orbit the star, and expected to have a cloudless atmosphere, or very low altitude clouds. It's also depleted in carbon as a relatively cool temperature of just 600 Fahrenheit, 317 Celsius, which is cooler than the majority of hot planets we've seen so far, and colder than Venus. Guatauba is named after a mythological figure in Taino mythology. There's also a candidate super-Jupiter planet in the system 6.5 AU away from the star, but it's unconfirmed. 44. Hike. Hike also has a planetary neighbor, though this one is unconfirmed, but might be a brown dwarf with a minimum mass 15 times greater than Jupiter's, 5 AU away from the star, similar to Jupiter and the Sun. Hike itself is a hot Jupiter, 58% Jupiter's mass, 22% larger than it in radius, and on a 4.3-day orbit around the star. Hike's exact color is unknown, but it seems to be redder than other observed hot Jupiters, which could be hinting at a unique chemical environment not seen on many other planets. However, it's currently unknown what's causing the difference in color. Hike's dayside temperature has been measured at 1,673 Fahrenheit, 912 Celsius, and has a cooler night side of 847 Fahrenheit, 453 Celsius. Hike is the successor to the god of the sea in Tagalog mythology. 43. Drukgyal. Drukgyal has a pretty cool name. It's the ancient name for the country of Bhutan, but also translates to Land of the Thunder Dragon. Drukgyal orbits a subgiant star currently about 3.3 times brighter than the Sun at a distance of about 3 AU, and from what I can tell, seems to be on the outer edge of its star's habitable zone, though that's just my own estimate based on its luminosity and hasn't actually been directly said anywhere. Drukgyal has a minimum mass similar to Jupiter's, and because its star is a subgiant, it may not have been in the habitable zone before, and has since entered it, which is pretty interesting. 42. Bendita. Bendita orbits a star called Tangra that is a member of the Milky Way's thick disk, a collection of old stars. The age of Tangra is poorly constrained, but it may be between 7 and 12 billion years old, likely making Bendita an old planet as well. Bendita is another puffball, 27% the mass of Jupiter, but 16% larger than Jupiter in radius, on a 4.3-day orbit around the star. Analysis of the planet in 2020 also found it contains sodium and is mostly cloudless. Bendita is named after Bendis, a goddess worshipped in ancient Thrace. 41. Belisama. Belisama is at least 2 Jupiter masses, with a pretty eccentric orbit around its F-type star. It has an estimated equilibrium temperature of 181 Fahrenheit, 83 Celsius, which is below the boiling point of water, but doesn't take into account temperature variations Belisama will experience on its eccentric orbit or any potential atmospheric effects. It has an eccentricity of 0.37 and gets as close to its star as 0.48 AU, and as far out as 1.04. Belisama is named after the Gaulish goddess of fire, which is similar to the Roman god Minerva. 40. Boinayel. Boinayel is a Taino deity of rain, though the planet that got named after it has a measured temperature of 1763 Fahrenheit, 962 Celsius, though has been found to contain water vapor in its atmosphere. Boinayel is another low-density planet, 48% Jupiter's mass, but 1.2 Jupiter radii. Its atmosphere is also known to be hazy, which scatters light and makes atmospheric characterization difficult. There's evidence for sodium and potassium in Boinayel's atmosphere, but it's not conclusive. It takes 3.3 days to orbit its star, which is just 60% the brightness of the Sun. 39. Boca Prinz. WASP 39b, named Boca Prinz, is coincidentally the 39th planet on this list, and is another low-density gas giant, the first planet outside the solar system found to contain carbon dioxide. Sodium and sulfur were also detected on it, as well as a spectrum that suggests the atmosphere is only partially cloudy. Boca Prinz is named after a beach in Aruba and is just 27% the mass of Jupiter, but 27% larger than Jupiter in radius. It takes 4 days to orbit the star Melmoch, which is 93% the mass of the Sun and has evidence of a debris disk or asteroid belt 2 AU away from the star. Boca Prinz is tidally locked to Melmoch, but interestingly, the part of the planet that experiences eternal evening is a few hundred degrees hotter than the hemisphere with eternal morning. 38. Nachtwacht. Nachtwacht, named after a Dutch name for the Dutch painting The Night Watch, is another planet with a highly inclined orbit. Nachtwacht's orbital inclination is 166 degrees, meaning it orbits its star, which is named Sterrennacht after the Dutch name for Van Gogh's Starry Night painting, nearly upside down. This was the first planet with a retrograde orbit on this list, but won't be the last. Other than its weird orbit, Nachtwacht is a fairly typical hot Jupiter, 1.1 Jupiter masses and 1.3 Jupiter radii, taking 3.8 days to make a full orbit of its star. 37. Barragil. Barragil, named after a type of wind tower used in the United Arab Emirates as a form of air conditioning, has a high eccentricity of 0.29 and is between 0.25 and 0.46 AU away from its star on a 111-day orbit. Despite this pretty close orbital distance, Barragil is a pretty cool planet because its star Sharjah is a red dwarf just half the mass of the Sun. Its eccentric orbit will likely cause temperature variations, which will happen in the form of wind, and since Barragil is used for air conditioning, its name is pretty fitting. It's at least 2 times the mass of Jupiter, which is pretty interesting because small stars like Sharjah shouldn't have this large planets, but it also makes sense given Sharjah has a metallicity 2.5 times greater than the Sun. There's also hints of a larger outer planet 11 times more massive than Jupiter, between 5 and 12 AU away from the star, but it's unconfirmed. 36. Able. Able is the first named exoplanet going alphabetically, and is named after a traditional coffee ceremony in Ethiopia. It has a minimum mass of 4.8 Jupiter masses, but astrometry observations have shown its true mass is likely closer to 5.9. It has a high eccentricity of 0.67, and is on average about 2 AU away from the star, which is 3.3 times brighter than the Sun. This means that, again, as far as I can tell, Able passes through the habitable zone of its star, but doesn't stay in it for long due to its elliptical orbit. 35. Finlay. Finlay is extremely similar to Able in mass, orbit, and temperature. Its true mass has been estimated using astrometry to be about 5.3 Jupiter masses, and it has a high eccentricity of 0.54, is usually about 1.3 AU away from its star, and seems to pass through the habitable zone. However, Finlay's star Felix Varela, named after the first person to teach science in Cuba, Felix Varela, is just 20% as bright as the Sun. Finlay is named after Juan Carlos Finlay, a Cuban doctor who studied yellow fever in the 1800s. 34. Vlasina. Vlasina's star Morava doesn't show any noticeable star spot activity, which is odd because it seems to be young, with an estimated age of 1.7 billion years, though different studies have given very different numbers than that. It may be a possibility that Morava is an older star that is for some reason spinning faster than stars of its age should be. Either way, Vlasina is another hot Jupiter like Nachtwacht on a retrograde orbit, orbiting the star upside down and the opposite direction it should be. It's about 56% the mass of Jupiter, 1.2 Jupiter radii, and on a 4.3-day orbit around the star. It has an estimated equilibrium temperature of 2202 Fahrenheit, 1206 Celsius, though this has not been directly observed. Vlasina and Morava are both named after rivers in Serbia. 33. Makombe. Makombe is also named after a river, though this one is in Cameroon instead of Serbia. It's on a 3.8-day orbit around the star, 26% the mass of Jupiter, and 94% Jupiter's radius. Makombe's atmosphere is known to be hazy and also contains an amount of water similar to, or a bit higher than the solar system planets. However, what makes Makombe interesting is this planet is evaporating extremely quickly, and has a massive comet tail 7 times wider than the planet itself. Makombe is estimated to be losing about half an Earth's worth of mass every billion years, which is much faster than Iztok if you remember that one. Makombe's atmosphere is also partially cloudy and contains sodium, though interestingly, it's a possibility the sodium doesn't originate from the planet itself. I'll talk about this more in depth when we get to Tylos, but it may be a possibility that sodium in Makombe's atmosphere could be there because of volcanic eruptions on exomoons, but this is not confirmed. 32. Gökturk. On many hot Jupiters, and most of the ones we've seen so far, the common theme is high winds and significant temperature differences between the day and night sides. For some reason, Gökturk doesn't have this. It's 46% the mass of Jupiter, 1.27 Jupiter radii, and on a very short 1.7-day orbit around its star, making it a typical hot Jupiter. Gökturk's dayside temperature is 2206 Fahrenheit, 1206 Celsius, but its nightside is 1743 Fahrenheit, 951 Celsius, which is still a noticeable difference but not nearly as high as the other hot Jupiters. Gökturk also doesn't have high winds and has low-lying clouds, suggesting it's not very rich in metals. It seems to be fairly calm, at least for a hot Jupiter. Like Makombe, sodium has been detected here, which could be due to volcanic moons, but that's not actually confirmed. Gökturk is named after the Gökturks, a group of people that lived in Inner Asia in the medieval times. 31. Wadi Rum. Wadi Rum's star Petra is just 9% the mass of the Sun, but Wadi Rum is still a pretty hot gas giant on a 3-day orbit around its star. Wadi Rum is named after the Wadi Rum Valley in Jordan and is 57% the mass of Jupiter, and extremely similar to Jupiter in radius. Wadi Rum's dayside temperature is 1221 Fahrenheit, 664 Celsius, and its nightside is 1072 Fahrenheit, 578 Celsius. Wadi Rum was found by James Webb to contain methane, which was pretty significant at the time of its discovery because methane is hard to find in exoplanet atmospheres, as well as water vapor. Wadi Rum also likely has a low albedo. 30. Baiduri. Baiduri is another extremely eccentric planet with a very high eccentricity of 0.75. It gets as far away from its star as 1.66 AU and as close as 0.24, which is close to the distance between Mercury and the middle of the asteroid belt. Biduri is named after the Malay word for opal, and again, from what I can tell, passes through its star's habitable zone, but obviously doesn't stay inside it. Its star is just 25% the brightness of the sun, so Biduri likely spends some time outside the habitable zone on both the cold and hot ends. 29. Sapphire. Sapphire is the innermost planet of the Upsilon Andromedae system, and the second member of its system on the list so far. Observations of Sapphire indicated the planet may be blue in color, though this is unfortunately inconclusive and unable to be confirmed. Sapphire, despite being 2.8 Jupiter masses, is the smallest known planet in its system and a hot Jupiter, taking 4.6 days to orbit its star and is 1.8 Jupiter radii. Its atmosphere is being inflated by stellar heat, so Sapphire is likely the largest planet in its system in radius, despite being the least massive. Sapphire's presence also induces a bright spot on its star Tidewin, which might be caused by magnetic fields of the two objects interacting. 28. Bonxia. Bonxia is a very hazy hot Jupiter, with observations indicating there's a strong haze layer scattering light on the planet. Its atmosphere has also been found to contain sodium, water vapor, and titanium oxide, and Bonxia was actually the first exoplanet where titanium oxide was detected. There's also evidence of carbon monoxide and dioxide in it. Bonxia has an extremely high dayside temperature of 3572 Fahrenheit, 1967 Celsius, and is 10% larger than Jupiter in radius and 40% larger in mass. Data from the TESS telescope also suggests that Bonxia's atmosphere is pretty good at transferring heat, so its night side should be very hot as well. Bonxia is named after a type of Australian wildflower. 27. Aegir. Aegir is the closest officially named exoplanet to Earth at just 12 light-years away, orbiting the star Ron, also known as Epsilon Eridani, which is visible without a telescope. It's named after the god of the sea in Norse mythology, and is extremely similar to Jupiter, making it one of the best Jupiter analogs found so far. Aegir is 1 Jupiter mass on a circular 7-year orbit around its star, and has an estimated temperature somewhere between -190 and -100 Fahrenheit, -123 to -73 Celsius. Aegir is the most Jupiter-like exoplanet found to date, which provides some hope that the Epsilon Eridani system could be structured similarly to our own, with inner rocky worlds. However, so far, no other planets have been confirmed in this system. 26. Sancho. Sancho is the last of Muare's 4 planets, and is another Jupiter analog like Aegir, though not nearly as similar. Sancho is at least 1.9 Jupiter masses, and 5.2 AU away from its star. Its orbit is a bit eccentric, though still mostly circular, with an eccentricity of 0.09. Other than that, we don't know much about it, but it should likely be similar to both Jupiter and Aegir, just a bit larger. 25. Aziae. Aziae is another retrograde hot Jupiter orbiting its star upside down, but this time it's also a puffball planet. Aziae is just half the mass of Jupiter, but 1.4 Jupiter radii, which is not only pretty big for a puffball, but its estimated temperature of 2514 Fahrenheit, 1379 Celsius, may not be enough to cause its atmosphere to expand this much. It's been suggested that Aziae may be generating internal heat, which would provide the necessary extra heat to puff out its atmosphere like this. Other than that, Aziae takes 3.7 days to orbit its star and is named after an Earth goddess from Akan mythology. 24. Kruenloch. Kruenloch is the 3rd planet to be named after a word that's supposed to roughly translate to orbit, after Orbitar and Neufusui, this one in the Manx Gaelic language. Boring and uninspired name aside, Kruenloch is another strange puffball planet. According to the paper that discovered it, Kruenloch's low density could be caused by the planet having an extremely small core or no core at all, though this was published in 2009 when we knew a lot less about puffball planets, so I'm unsure if it still holds up today. This planet is 48% the mass of Jupiter, but 36% larger than it in radius, and has an estimated temperature of 1981 Fahrenheit, 1083 Celsius. 23. Poiera. Poiera is yet another puffball, but on a weird orbit. Instead of orbiting upside down in a retrograde direction like Aziae, Poiera is on a polar orbit, meaning it orbits roughly perpendicularly to its star's equator. It's also a very large puffball with a mass 83% that of Jupiter, but a radius 75% larger. Its atmosphere is also made up of 1% water vapor, and contains iron hydride molecules as well as sodium and possibly vanadium oxide. Poiera is named after a traditional dress from Panama. 22. Ditso. I'm not sure how to pronounce that accent mark on the O, but Ditso is named after the name the god Saibo gave the Bribri people in Talamaccan mythology. Ditso is not only a puffball on a retrograde orbit, but it's one of the least dense planets ever found. Despite being only half the mass of Jupiter, Ditso is nearly double the radius of Jupiter, and so has an extremely low density. It's not even that hot compared to some of the other puffballs, with an estimated temperature of 2330 Fahrenheit, 1277 Celsius. Its especially low density is expected to be due to tidal forces from the star. Ditso has been observed by James Webb and found to have clouds made of evaporated silicon dioxide, which on Earth is better known as the mineral quartz. 21. Amaterasu. Amaterasu, which was supposed to be named Amaterasu after the Japanese sun goddess, but couldn't because an asteroid already had that name, was the first planet found in an open cluster. Specifically, Amaterasu and its star Ein are members of the Hyades, a star cluster visible from Earth without a telescope near the Pleiades. This is a group of a few hundred stars that are all moving together because they formed at the same time, roughly 600 million years ago. Amaterasu is at least 7 times more massive than Jupiter on a 586-day, 1.87 AU orbit around its star, which is 2.4 times more massive than the Sun. This large mass is the reason why, despite being just 600 million years old, Ein is already a red giant star 80 times brighter than the Sun, even though it hasn't even left the cluster it was born in. 20. Kuakua. We are 144 planets into this list, and Kuakua is the first rocky planet in this entire video. It was named after the Berber word for butterfly in 2022, when the IAU decided to start just naming scientifically interesting planets instead of trying to be fair to every country. Kuakua is a super-Earth about 2.3 Earth masses and about 28% larger than Earth in radius. It's been observed by James Webb and found to likely be an airless rock with no significant atmosphere. This is because Kuakua is a very hot planet with a dayside temperature of 1313 Fahrenheit, 712 Celsius. But it doesn't have an atmosphere to transfer heat, so Kuakua's nightside is likely extremely cold. Kuakua is likely airless because of stellar radiation blasting its atmosphere away, and because of high-velocity impacts which are also capable of eroding atmospheres. So Kuakua is basically a hotter, bigger version of Mercury, but because it's one of a very small handful of named rocky planets, it starts the top 20 most interesting named exoplanets. 19. Su. Su is another rocky planet a bit more massive than Kuakua at 2.7 Earth masses, but of similar radius. It's named after the Basque word for fire, which makes sense because, like Kuakua, Su is extremely hot with a dayside temperature of 1097 Fahrenheit, 592 Celsius. Also like Kuakua, James Webb observations have indicated that Su has no significant atmosphere. It was originally thought it may contain water vapor, but that turned out to likely be stellar noise contaminating the signal, and Su is likely another hot, airless supermercury. It takes 1.4 days to orbit its star, named Gar, which is just 1% the brightness of the Sun, but that doesn't stop Su from being extremely hot nonetheless. 18. Pipitea. We're back to gas giants with this one. Pipitea was mentioned in the same study as Melquiades and Perwana that might be capable of hosting stable, planet-sized objects in its orbit, but again this is an old study and may not hold up today. Pipitea is at least 3.1 Jupiter masses, but observations from Gaia have suggested it's much larger. It's less than 40 Jupiter masses, but observations from Gaia show, with 68% confidence, that Pipitea is between 10 and 20 Jupiter masses. So it's not confirmed, but Pipitea is likely much larger than its minimum. However, its orbit is roughly circular, and it stays in the habitable zone the entire time, which is good. Pipitea's large mass suggests it could theoretically host large moons, which we'll talk about more when we get to Majority, and it has the unconfirmed potential possibility of maybe being able to host Trojan planets as well, which is pretty cool. It's named after a type of pearl found on the Cook Islands. 17. Qingluan. And now we're back to rocky planets. Qingluan is named after a Chinese mythological bird, and it's the largest rocky planet on this list so far, about 4 times the mass of Earth and 63% larger than it in radius. However, like Kuakua and Su, Qingluan is another hot planet on a 1.4-day orbit around its star. James Webb observations have shown no atmospheric signatures, but it wasn't enough data to fully confirm Qingluan is airless. That remains a strong possibility, but an extremely dense carbon dioxide atmosphere similar to Venus's has not yet been ruled out by the data. So Qingluan has a good chance of being an airless supermercury like Kuakua and Su, but a super Venus is not yet off the table. Its star is just 7% the brightness of the Sun, but that doesn't stop Qingluan from having a dayside temperature of 1337 Fahrenheit, 725 Celsius. 16. Mentone. I have a full video about this whole system, but Mentone is a member of the 3-planet HD 208487 system, and the reason it's so high on the rankings despite being a normal high eccentricity warm Jupiter is because of how it may have formed. Again, the video What Happened in HD 208487 explains this better. I don't want this video to be much longer than it already is, so I won't go into too much detail, but the orbital arrangement of the 3 HD 208487 planets, of which Mentone is the innermost, suggests it should have formed with more planets, and that the 3 we see today are survivors from a series of massive collisions. Mentone, which is at least half the mass of Jupiter on a 129-day orbit with an eccentricity of 0.37, may have formed as a result of a 3-planet collision, which seems like it should be pretty rare. The other 2 planets are of similar mass and may have formed in a similar way. Mentone is named after a mythical land where brave men live in Fang folklore. 15. Majority. We now get to the last planet in the Upsilon Andromedae system. Majority is of similar mass to its neighbor Somme, about 10 Jupiter masses, and entirely within its star's habitable zone on a 3.5-year, somewhat eccentric orbit with an eccentricity of 0.3. Because of its high mass, like Pipitea, Majority could theoretically host some pretty large moons, with Earth-sized ones not out of the realm of possibility. While no moons have been confirmed around Majority, the possibility of it makes this planet pretty scientifically interesting, which is why I'm putting it at the number 15 spot. Majority itself has an estimated equilibrium temperature of -67 Fahrenheit, -55 Celsius, though because it's a large planet, it's likely to be generating its own internal heat and will probably be hotter than that. And as mentioned earlier, Majority pulls on Somme's orbit, causing it to become circular every 9,000 years. 14. Awohali. You might know Awohali as Gliese 436b, since it's one of the more popular exoplanets due to the now inaccurate idea that its core is made of burning ice. Awohali is a hot Neptune about 21 times the mass of Earth and very similar in radius to Neptune, with, like Macombe, a comet tail significantly larger than the planet itself. It was originally thought that Awohali's density needed to be explained by a core made of exotic forms of hot water ice, but when its radius was better constrained, this was no longer a necessity. However, Awohali may also be an example of a helium planet, a rare type of gas giant with more helium than hydrogen in its atmosphere. Awohali is not confirmed to be a helium planet, but it is a candidate for one, since its comet tail may be made of hydrogen escaping into space and leaving helium behind. Awohali takes 2.6 days to orbit its star but has a decently low temperature of 733 Fahrenheit, 390 Celsius. It's named after the Cherokee word for eagle. 13. Tahe. Tahe is another rocky planet and has the shortest orbit of any planet in this video, with its year lasting just 7.7 hours. This is where it gets its name from, Tahe being a Chilean wildflower that only blooms for 7 or 8 hours at a time. It's also the smallest planet so far, just 63% the mass of Earth. It's also very dense, with a radius 70% that of Earth's, suggesting it has a large metallic core similar to Mercury. It also has a dayside temperature of 2651 Fahrenheit, 1455 Celsius, and likely doesn't have an atmosphere. Tahe is also neighbored by 2 super-Earths, GJ367c and D, which are both at least 4 times the mass of Earth, making Tahe the smallest planet in its system and pretty much just a hotter, bigger version of Mercury. 12. Nysacopaque. Nysacopaque, meaning Mother Earth in the Zoc language, was the first exoplanet directly imaged by James Webb. It's an extremely young gas giant, just 14 million years old, meaning it's still in the process of forming. This is why, despite being somewhere between 56 and 195 AU away from its star, significantly further than Neptune from the Sun, it's 1850 degrees Fahrenheit, 1010 Celsius. It hasn't yet cooled down from its formation. But for some reason, Nysacopaque is not surrounded by a debris disk, like planets of its age should be, which is against models of planetary formation and pretty weird. Nysacopaque is also 7.1 Jupiter masses, 44% wider than Jupiter in radius, and has an unconstrained eccentricity, so we don't know how eccentric its orbit is. We do know, however, that Nysacopaque has clouds made of vaporized enstatite rock, but that this atmosphere isn't dusty, which it would be if it had a debris disk. 11. Astrolabos. Astrolabos, named after the Greek word for the astrolabe, is a hot Jupiter, but a very well-studied run, which is why it gets the number 11 spot. Astrolabos is a hot day side of 2203 Fahrenheit, 1206 Celsius, but a much colder night side of just 899 Fahrenheit, 482 Celsius. It's about 2 times the mass of Jupiter, but similar to Jupiter in radius, and has an extremely short orbit of 0.8 days due to its star's lower mass. Interestingly, James Webb observations suggest Astrolabos has no clouds on its day side, but cooler temperatures mean it does have clouds on the night side. It also has a hydrocarbon haze and likely a variable amount of carbon dioxide concentration. It's been theorized that Astrolabos' orbit should be decaying, but no orbital decay has been detected as of 2021. We're now down to the top 10, with Enaiposha. Enaiposha is an 8.4 Earth mass, 2.7 Earth radii hot planet orbiting the red dwarf Orcaria on a 1.5-day orbit. Enaiposha literally means large body of water in the Ma language, and it was named that due to its density, which suggested at the time that Enaiposha was made of a significant amount of water. However, it's a very hot planet, which would have made Enaiposha a steam planet with an extremely thick atmosphere over a supercritical water ocean. However, James Webb observations later confirmed this was untrue, and that Enaiposha actually has a cloudy, metal-rich atmosphere, and is likely more similar to an extremely hot super-Venus. Enaiposha's dayside temperature is 537 Fahrenheit, 280 Celsius, while its night side is 327 Fahrenheit, 164 Celsius. According to a 2024 study, its atmosphere may be rich in carbon dioxide, making it even more similar to Venus, but so far there have been a ton of different papers all suggesting slightly different things for Enaiposha's atmosphere, so its exact composition is not currently known, just that it's rich in materials heavier than hydrogen or helium. 9. Quankoa. As of the time of making this video, Quankoa is the brightest known planet in the universe, with an extremely high albedo of 0.73, though it may be as high as 0.84, which is higher than Venus's of 0.76. This means that Quankoa reflects roughly 73% of the light that hits it back into space, and this is likely due to a layer of reflective clouds made of silicate materials. Quankoa is also a rare hot Neptune in the Neptunian desert, with a dayside temperature of 3608 Fahrenheit, 1987 Celsius. It's named after the name for a morning star in the Yuwa language, the object we now know as Venus. 8. Tylos. Tylos is another extremely well-studied hot Jupiter, with very detailed simulations showing how weather patterns on this planet might look like, as seen here. Like Macombe, sodium in Tylos' planetary atmosphere may indicate the presence of volcanic moons, and evidence for this is further found in a torus of sodium gas surrounding the planet. Tylos is 15% more massive than Jupiter, but 70% larger in radius, and extremely hot, with a short orbit of just 1.2 days. Chemical analysis of its atmosphere also confirms Tylos did not form where it is today, and likely formed around 20 AU away from its star, around where Uranus is around the Sun today, before spiraling inward and becoming a hot Jupiter. I have a full video about this as well. Tylos' dayside temperature is extremely high, 4,224 Fahrenheit, 2329 Celsius, and its atmosphere is composed of 3 distinct layers. An upper layer made of hydrogen, a middle layer containing sodium, and a lower layer of evaporated iron. Tylos is one of the most well-studied hot Jupiters we know of so far, and is named after the ancient name for the country of Bahrain. I'm going to be combining planets 7, 6, and 5 because they're all part of the same system: Draugr, Poltergeist, and Phobator. This is a trio of 3 rocky planets orbiting the neutron star Lich, the leftover remnant of a star that went supernova. So far, very few planets are known to orbit pulsars like this, and we have never seen a system that looks like this before. These are the only known rocky planets to exist around pulsars, and Draugr is one of the smallest exoplanets known, slightly more than twice the mass of the Moon. Its 2 neighbors, Poltergeist and Phobator, are both about 4 times the mass of Earth. All 3 planets are likely to be extremely cold because Lich is a very small and dim star, though likely massively irradiated. It's unknown if these 3 planets survived their star's supernova and then spiraled inward or formed after the supernova. But this is an extremely interesting system, and we've never seen anything like it, even among other pulsar planets. Which makes it even more interesting that these were the first exoplanets ever confirmed to exist outside the solar system, found with pulsar timing variations. The star and its 3 planets are named after various undead creatures and ghosts in various mythologies, which makes sense given they orbit a dead star. I originally had these planets at 1st, 2nd, and 3rd place for most interesting exoplanets, but because we know nothing about these things beside they exist and their orbits and masses, despite being arguably the most unique exoplanets ever found, I don't think they fully make the top 3 and want to put the spotlight on some others. 4. Levantes. Levantes is very similar to Nysacopaque in that it's a very large, very young gas giant, very far from its star, still in the process of forming. Levantes is about 13.3 million years old and about 5 Jupiter masses, between 51 and 73 AU away from its star Aeolos, which is about 60% more massive than the Sun. Aeolos is surrounded by a warm and cold debris disk, with Levantes in between the two. It's been proposed that Levantes began forming closer to Aeolos before being scattered away onto a further orbit, but this has not been confirmed. What is confirmed, however, is that unlike Nysacopaque, Levantes does have a very dusty atmosphere, potentially due to the presence of a debris disk around it that's in the process of forming moons. However, James Webb observations disfavor the presence of a disk like Nysacopaque, which is kind of weird. This dust also likely makes Levantes' atmosphere much redder than other gas giants. Because this planet is so large, it influences Aeolos' two debris disks, carving gaps in the disk, specifically a sharp drop-off in material at the inner edge of the cold disk, though additional planets in the gap are also a possibility. Levantes is the Greek word for Eastern Mediterranean winds. 3. Ara. Ara is another large planet, possibly about 7 Jupiter masses. However, it has the widest orbital separation with its star of any planet on this list, orbiting its star Maru at 2,500 AU, nearly 100 times further out than Neptune orbits the Sun, and similar to the distance between the Sun and the start of the inner Oort cloud. This is also one of the widest separations between planet and star known among any exoplanet. Also, Maru is a white dwarf, the remnant of a star similar to the Sun after it's become a red giant. Maru likely used to be about 2.1 times the mass of the Sun before becoming a white dwarf, and shows what systems like the ones with the planets Arbor and Amateru will eventually be like. Ara is often called a sub-brown dwarf because this large distance is more similar to the separation of binary stars than planets, suggesting Ara may have formed like a star but didn't get enough mass to fully become one, leaving it as a sub-brown dwarf. This planet has been observed by James Webb and found to contain water, ammonia, carbon monoxide and dioxide, and hydrogen sulfide, as well as the usual hydrogen and helium. However, there's some uncertainty over Ara's age and mass. A 2025 paper found a very different, much smaller mass for Ara, which would indicate that they just got the mass wrong, which seems to be possibly the more likely option, or that Ara's age is wrong. I have a full video about this as well, but basically, if Ara is smaller than expected, it would also have to be younger than expected, because it has a temperature of 182 Fahrenheit, 84 Celsius. It's too far away from Maru to be heated by it at all, so must either be large enough to retain heat well, or young enough to still be that hot. If the second option is true, then Ara must be significantly younger than Maru, indicating it didn't form alongside it and may be a captured rogue planet. If that was true, this would easily put Ara at the number 1 spot in my opinion, but because this is unconfirmed, and there is the very likely possibility that the paper just got the mass wrong, I'm keeping Ara at number 3. It's either a very large, very distant gas giant around a white dwarf, or, much less likely, it's a younger, smaller, captured rogue planet. Its name is the Korean word for ocean. 2. Pylincium. Pylincium is another planet where, like Ara, it would be number 1 if one pretty unlikely scenario turned out to be true, but since it's unconfirmed, I'm leaving it a bit lower. Pylincium is another hot Neptune in the Neptunian desert, but like Poiera, is on a rare polar orbit where it orbits perpendicularly to its star's equator once every 3.3 days. Pylincium is about 14 Jupiter masses, a bit smaller than Neptune, and is about 752 degrees Fahrenheit or 400 Celsius. It's evaporating at a very similar rate to Macombe, losing about half an Earth mass every billion years, and has a very large comet tail. Due to some observations of the planet, it's thought that Pylincium might appear blue to the human eye due to Rayleigh scattering, though later observations suggested that Mie scattering, a stronger type of light scattering than Rayleigh, isn't present. Sodium dioxide, which indicate there's chemical reaction to the atmosphere triggered by stellar radiation, was also found, as well as water vapor, which may be filling the entire Roche lobe of the planet. However, what makes Pylincium deserving of the number 2 spot, and if it was confirmed, the number 1, is the potential for another planet sharing its orbit. A 2024 study identified an unconfirmed potential Trojan planet in Pylincium's L5 Lagrange point. As I've mentioned earlier, the Lagrange points of Melquiades, Pipitea, and Perwana might be stable for Trojan planets, but no evidence of that has actually been detected. For Pylincium, there may be a small rocky Trojan planet about 2.6 Earth masses sharing its orbit. However, this is highly unconfirmed, and there's been no new data on this potential Trojan planet since 2024 when it was first proposed, so it remains only a tentative candidate for now and far from confirmed. It's based on radial velocity data, but if it exists, it doesn't transit the star like Pylincium does, indicating either that it doesn't actually exist, or that its radius isn't larger than Earth's, which would make it a very dense object. So there are some good reasons to doubt the validity of this Trojan planet candidate, but there does remain a slight possibility that it exists. Pilentium is named from a Thai name for the blue Siamese sapphire, alluding to its potential blue color. And finally, the number one most interesting officially named exoplanet, Janssen. Janssen is another pretty well-known planet you might know as 55 Cancri e. This 8 Earth-mass hot super-Earth orbits the orange dwarf Copernicus, which is a binary system with at least 6 confirmed planets and 2 more unconfirmed, many of which were also on this list: Galileo, Braia, Harriet, and Lippershey. Janssen is likely covered in a global lava ocean, given an extremely high dayside temperature of 6,328 Fahrenheit, 3,500 Celsius, the hottest planet with a confirmed measured temperature in this whole video. The night side is significantly cooler, 2,509 Fahrenheit or 1,376 Celsius, which is a very large difference. Janssen is also expected to have an atmosphere, the first and only rocky planet in this video where an atmosphere is likely. It could be extremely dense and made of carbon monoxide and dioxide, though it's not entirely confirmed yet and there's still a lot of uncertainty around it. Janssen is also potentially carbon-rich based on its star's high carbon-to-oxygen ratio, though this is also not confirmed. This is where the myth that Janssen is made of diamonds comes from, which is most likely untrue. Diamond isn't the only structure carbon can form, and while Janssen may have a lot of carbon, it could be locked into different compounds, and while there may be a lot of diamond, it almost certainly won't be the entire structure of the planet. Janssen is about 85% larger than Earth in radius, making it the widest rocky planet in this video, as well as the most massive, being about 8 Earth masses, close to half the mass of Neptune. Usually rocky planets don't get this big, but Janssen is, likely because it's being blasted with such intense radiation from Copernicus, its larger atmosphere got blasted into space. Janssen takes just 18 hours to complete an orbit, which is more than Tahe, but still very short. Janssen also likely has significant volcanic activity based on variations in the amount of light coming off the planet. All in all, Janssen is one of the most well-studied exoplanets in general, and definitely one of the most well-studied rocky ones, and one of the most popular exoplanets online, which is why I think it's deserving the title of most interesting exoplanet with an official name. So that's all 164 exoplanets with official names, ranked from least to most interesting. This will still likely constantly be changing as we discover more about these worlds. I actually tried to make this video 2 years ago but ran out of time, but in that time span my rankings completely changed, and the list I have now is very different from the list I originally made in 2024. And this list will likely continue changing into the future, especially as, hopefully, more exoplanets get official names in the coming years. We're due for more since the last ones were named back in 2022. With 164 planets, new things are constantly being learned, and planets I ranked at the bottom may have something interesting about them we haven't discovered yet. But those are my personal rankings for now. Thank you for watching. If you enjoyed, check out my other videos about exoplanets and space exploration.